To show you how this will be histogramming. It's going to look like a histogram, but qualitatively. I'm going to collect some data from you, though. I want you to clear your minds. What I want to do is I want to ask you a series of arithmetic questions that I want you to answer mentally, just quietly in your mind. And then at the very end of a bunch of arithmetic questions, I'm going to ask you a non-arithmetic question that I want you to answer. And then I'm going to collect those responses. That'll be our data. So I'm going to ask you a bunch of math questions, just answer them quietly in your mind. And then I'm going to ask you a non-math question, answer that quietly in your mind, and then I'll collect the non-math responses. Here we go! Clear your minds. 1 plus 5, 2 plus 4, 3 plus 3, 2 plus 4, 5 plus 1, 0 plus 6, 3 plus 3, 1 plus 5, 2 plus 4, 3 plus 3. Think of a vegetable.
Onion.
Okay. We'll see how many onions we get now. Everybody got a vegetable? All right, we got onion. Anybody get onion? 26 people. No, I'm kidding. One onion. Good, very good. Others?
Carrot.
Carrot.
Celery.
Oh, hang on a second. How many carrots did we get? Let's collect them. Oh! 2, 3, 4, 5, 6, 7, 8, 9, 10. Celery. How many celeries? 1. Let's get 2 more. Broccoli. Tomatoes and fruit. Broccoli. I heard a great quote once. Wisdom is knowing a tomato. No, knowledge is knowing tomato is a fruit. Wisdom is knowing not to put it in a fruit salad. I love that. Broccoli. How many broccolis we got? 1, 2, 3. And what the hell? Let's do tomato. Tomato? Just 1? There was 2. Okay, one of us. Perfect. I don't know why. Everybody always says carrot. Everybody. People used to say carrot and broccoli, but I changed my lesson to avoid that because I used to say how many people like earlier like about an hour ago I asked how many of you like broccoli? How do you know? You haven't eaten it all. And that was my point about drawing a sample, was you'd have a sample of broccoli, you like the sample, so you probably like broccoli. And I was inadvertently skewing the results by saying that. So I took the broccoli out and broccoli went down. I cannot explain carrot. Harrison, you can.
There's a correlation between carrot being a 6-letter word and then everything you saying added up to 6.
I don't know. Something about those 6 letters, right?
Yeah.
I wish I had an answer. I don't. My mom sent me this email like 15 years ago with all the math problems. I'm thinking of a vegetable. I said carrot. I don't know what it is. It's just there. I wish I had a better answer than that, but I don't know why. So the reason it's called a Pareto diagram, you see how this is qualitative? Because I asked you to write a vegetable down, not a number down. I write a vegetable down. So what you're now going to do is you're going to emphasize the fact that so many of you said carrot. You're going to list the categories the vegetables said across the bottom. We're going to go with carrot first. Then we're going to go with the next one was broccoli. And then we're going to go with the rest of them matter. Onion, celery, and tomato. And I'm sure a bunch of you said like asparagus and potatoes and all that kind of stuff. You say that again?
It's not a vegetable.
Asparagus isn't?
No potato.
It's not?
No.
What is it, tuber?
Starch.
Okay, it's
Starch.
starch. Potato,
Okay, I thought
potato, But the point is that the remainder of the results are all spread all over the place, right? Who said potato? There we go. It's not a tuber. It's a tuber. But the thing is that a third of you said carrot, and the other 2/3 of us were spread out. Who knows why? I don't know why. I can't explain it. But we can represent that in a Pareto diagram by scaling. Now we get up to 10. I'm going to make this go up to 12. Let's go with you guys, just to make it a nice split. I like to make my histograms go a little bit higher than the highest data point to give it some breathing room. We'll deal with that in the TIs starting next week. Carrot goes to 10. Broccoli goes to 3. And everything else is 1. Anybody know if we were to connect that with a smooth curve, what's that look like? What kind of curve? Be brave.
Bell curve.
It looks like half of a bell curve. I wasn't thinking of that. I was thinking literally itself, if you were to do this. Think 111, maybe 105 if you took 105. Starts with an E, ends with exponential. That's right! It's an exponential decay model. And that's kind of the point. Pareto made a claim back in the 1800s, I think. He was an Italian dude. And he said 80% of the wealth is held by 20% of the people, called the Pareto Principle. And that's more true now than it's ever been before. And the point is that a high majority or a high chunk of the sample is represented in one or maybe two data points. So it's an interesting way of reinforcing that fact. By putting it in decreasing or increasing, you can flip it around too if you want to, decreasing or increasing order, you kind of reemphasize the fact that, wow, so many people say carrot. Kind of cool, kind of cool. So that's a Pareto. It's a way of dealing with qualitative data. There's a couple other histogram-y type things I want to do. But first, I want to revisit one statistical measure that you may have learned in the past and forgotten, or maybe you still know it. Here's three words: slaughtered, refused, finger. What's the average number of letters per word of those three words? What is the average number of letters per word for those three words? So I asked you to do the average.
6.
8. There's got to be more than 6. Well, I mean, it's got to be more than 6 only because the shortest one is 6 and the other ones are higher. So it's got to be a little bit higher than that. So we got 6, 8, and 11. 14. 7. Those are 7. So 6, 7 is 13. 11 is 24. Divided by 3 is 8. 8 letters per word. How's that sound? That's all that is. So what you just did was you did a quick little average. All an average is, we're going to deal with this on Tuesday too. You add everything up and divide by how many you got. Many of you probably don't know why you do that. We'll attack that on Tuesday, I promise you. But for right now, I'm going to ask you to do an average. I'm going to show you some words. I want you to approximate the average number of letters per word. You won't have time to do what you just did. Give you 10 seconds. Ready? Go. You're wasting time complaining. Okay. Those of you who didn't recognize that, I envy you, because it means you haven't seen the greatest movie ever made. Ever made. Yeah, who has not seen The Princess Bride? Oh, you've all, we're so envious of you guys, because you have not seen the greatest movie ever made. Which means you get to go see it for the first time. I'm so excited. There you go, Montoya, just soliloquy, six-fingered man, soliloquy. What I'd like you to do now is I'd like you to give me your best guess of the average length of those words, and give me something point something. Like the last one was 8, 8.0, 8.1, something like that. So let me hear some ideas. Anybody guess, would they guess 4 point something?
Yeah.
4 point, everybody go with 3 point something. No 3s, 4s. 7 point somethings, yes? Any 8 point somethings? Anybody above 8? So everybody's between 4 point something and 7 point something. This is the perfect time for what's called a stem and leaf plot. A stem and leaf plot is a fantastic way of taking widely varied data in one way that's also pretty concise in another way. You guys all guessed between 4 point something and 7 point something. That means I've only got 4 stems. I'm going to put the stems down this side. 4, 5, 6, and 7. I'm going to call these the stems. But now, I told you to give me a point, 0.1, 0.2, whatever it is. You're going to have up to 40 different numbers, depending on what point you used. Those will be the leaves. So what I want to do is, anybody that guessed 4 point something, just call out your point somethings.
2.
0.2.
5.
0.5. 0.7. Good. Totally fine. 5 point somethings. Call them out.
0.2.
0.2.
0.0.
0.8. 0.0.
7.
0.7.
3.
0.3. Got them all. 6 point somethings.
0.
I hear 2 2s, is that right?
3.
3.
1.
1.
0.
0. Okay. And 7 point somethings.
7.
7, I heard a 7, I heard a 3.
0.1.
0.1. 0.6. Somebody's hearing things. Who the hell's not voting? I'm kidding, I'm not really pissed. I'm just. It doesn't even matter if you're not voting. It's totally fine. You're getting the point across. I want to tell you a couple things. Some textbooks say that you should put those numbers in order. I say, I don't care if you do or don't. The important thing is that they're scaled properly. You see how this is a histogram? If you don't see how it's a histogram, turn your head, exactly, turn your head to the right, and you can almost see the bars. The size of the bars is dictated by how many numbers are in. So max, to come back to your question before, You actually get a histogram with the actual raw data in it. Now, why don't we just make stem and leaf plots for everything? Because that seems like a win-win, right? Anybody know the answer to that?
They can be really long.
Yes. The convenience of a stem and leaf is that you don't have very many classifications this way, but you could have a lot this way. So it actually saves time in collection. This happens quite a bit when you're out in the field doing data collection. As your smartphone dies or your computer software's battery dies, this is a really quick way of getting this kind of data down. If your data is very, very varied in both ways, it's a waste of time because you end up doing more work than it's worth. So you don't have to decide that. If I ask you to make a stem and leaf, I'll say make a stem and leaf on this data, and then you'll just do it. But as time goes on, you'll discover when it makes more sense to do one way or the other. Capish? It's quantitative data. I said give me an average. Just so you know, the average length of a word in that is about 4. I think it's 3.9 letters. And the reason we all overestimated it, which we all did, we always do, is why?
Second guess.
Why is that, Robert? Why's second guess?
Because you don't think sometimes that your first intuitive.
Was your first intuition lower than that?
It was.
Check you out.
Yeah.
Mine wasn't. Mine said it was like 7 or 8. Because my eye is drawn. Well, first of all, I showed you long words in the beginning. I showed you refused, I showed you slaughtered, I showed you fingered. There are tons of words. I, my, he, my. Tons of words that are short up there. And tons of words that are long, but all averaged together comes about 4. So that's the problem, is our eyes are drawn to the big ones. And plus I showed you big ones in the beginning. So. All right, one last one. One last one, and then I want to show you some interesting ones you won't be responsible for, but I couldn't help but share them with you guys because they're totally rad. Oh, I never took a picture of that stem and leaf. There's your stem and leaf plot. This will be so much better when I have a viewfinder. Keep an eye on what I'm doing. There we go. They also make a little, I might invest in this, a little GPS chip you can wear in your pocket and a little cradle, and the camera follows you around. Might go with that. Might go with that. Although that means the camera's on me the entire time. I don't think the world needs that. It's unfortunate. Here's the guy with the funny hair again. Dot plot. All right, I need some data. Clear your minds. I'm going to ask you a very simple question. Very simple question. I want you to think of a whole number from 1 to 4. What's it?
2, 4.
Hang on. I'm going to click one at a time. So, I like dot plots when you've got extraordinarily limited data. They're kind of like a stem and leaf, but it's when your data is even less varied than a stem and leaf data. I mean, there is no variance except there's 4 data points. 1, 2, 3, or 4. How many ones do we have? Let's see hands for ones. How many said 1? Nobody. Okay, cool. 2. Who said 2? 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to put 8 dots above that. So it's like a stem and leaf, and each of those dots is 1 data point, but you all said 2. There's no 2.1 or 2.2. Who said 3? Oh, yes. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18. And who said 4? I heard a couple 4s. 1, 2, 3. Yes, this is just about what happens every term. We get a spike at 3, a smaller spike at 6, and hardly anybody at 1 or 4. And why is that?
3 is the number of sugars.
Dude. Maybe. I don't disagree with you. 3 is a pretty powerful number. According to, what is it, the after school special, 3 is the magic number, that Blind Melon covered that song back in the 90s.
According to Newton.
Oh, very cool. I was just thinking the way I phrased the
It's the
statement.
only number you didn't say.
It's the only number I didn't say. I said think of a number, a whole number, from 1 to 4. And our brains just go, you didn't say that one. What's that?
I just didn't want to pick one on the end, and then I don't like even numbers.
Well, that's more thought than I put into it.
Yeah.
That's way more thought than I put into that game. Good for you. You want to, I want to take your data and make it meaningless. Thankfully, there's only one of you out of 30. Bunch of outliers in the class. Bunch of trouble-making, no-good youngsters. All right. So, those are the histogrammy types of plots. There are others. There are stem and leaves. There are box plots. There are ogives. There are frequency polygons. All kinds of wonderful stuff. We'll deal with them all in turn. What I want to spend the last few moments together with you guys doing is just I want you to kind of kick back, because there are plenty of statistical demonstrations that happen that aren't qualified by what